Good afternoon, everyone. My name is Tara Wilsworth. Welcome to our webinar with our series with Mark Rich and Paul Golden. Today we're going to be talking about aquaponics and greenhouses, and we have the two experts to tell us how to choose the correct and also to operate the correct setup. I'll introduce Mark. If you go to the next slide, we've got a couple of headshots and a couple of details with each. Mark, would you like to give yourself a little introduction?
Yeah, so my name is Mark Rich. I've been with Prospient for just a little bit over 6 years now. Focused a lot of my time on the systems engineering side of our business, and now operate as a regional sales rep for the Rocky Mountain region, as well as continuing to do some of the systems engineering side.
Okay, Paul?
Yeah, I'm Paul Golden. Been with the organization for 10 years now. Probably been involved in about 24 aquaponics projects over the course of the last 15, 20 years. And I operate as a sales director for the organization in the commercial market, primarily in the ornamentals, produce, and nursery markets in the U.S. And I'm looking forward to getting into this with you guys.
Great. If anybody has any questions, they can put them in the chat, and if they're relevant at the time, I'll ask them. If not, then we'll wait until the end and save a couple of minutes for questions that don't relate to the slide at the time. So with that, Mark, I believe you're taking the first slide.
Awesome. Thank you very much, Tara. So before we kind of dive into some of the technical side of things, we're just going to run through a real quick agenda here. So first, we're going to kind of talk about what is aquaponics and why the structure, whether it's the greenhouse or the processing house structure, matters. And then we're going to dive into what are the differences between a head house, fish house, processing house versus greenhouse. Sounds like there's a lot of components in one. How does the structure combine for all of those, and what to look for each of those. And then we're going to kind of dive into what is, plant health, fish health, how to help both of those, how to combine them together, how to make it everything operational together, and just how to make things more efficient. And then lastly, we're going to go into how can you automate, how can you help cut costs, save energy. And then lastly, we're just going to go into some aquaponic projects that Prospient has assisted on, and then kind of go through a Q&A. So if there's nothing else there, we will head on to the first slide. So what is actually aquaponics? And the way I try and talk about aquaponics is essentially merging hydroponics and aquaculture together to combine aquaponics. So essentially what it is you are taking waste from fish and utilizing that as nutrients, and typically a produce type of growing facility. And then the plants, which is typically produce that could be lettuce, tomatoes, any type of vine crop, is essentially cleaning that wastewater by uptaking the nutrients and filtering it back into the fish, whether that be in tanks, raceways, several different ways to actually grow the fish. And it's a symbiotic relationship that is able to be done year round. It's very sustainable. You can do it from whether it's commercial operation, which is kind of shown in this picture on the larger scale. You can do residential kind of on the hobby side. And then we also see a lot of different educational greenhouses do it for whether it be a high school, a college, just trying to introduce younger minds into what aquaponics is and the ideas behind it.
Mark, those tanks, are those the fish tanks?
Correct. Yep. So those are fish tanks there. They're circulating around. You can either have those, and you can see in this picture, there's 4 or 5 of them stacked horizontally there. Or you could also do raceways where you have much longer runs. In this one specifically, it was very small trout. So they're max growing 12 inches trout in here. So then the trout are just circulating around in that tank.
Okay.
So yeah, most people might think that aquaponics is a new area of study or a new area of interest, but in reality, it's been around for a long time. First commercial facilities started popping up in the late 80s, early 90s. And I'd say for the better part of the last 30 years, people have been building various different types of aquaponic systems at all different scales, mostly at your smaller, more like residential scale, but also some commercial scale projects. It's got its foothold on a lot of nations, a lot of island states, because of the food security concerns and the ability to be able to raise fresh produce without having to import it. And so you start to see it kind of pop up earliest in, like I'd say, the University of the Virgin Islands model about 30 years ago. And so it's diverged quite a bit since then. It's changed into all these different types of growing. That model used primarily deep water culture and actually didn't even utilize a greenhouse. And we'll get into the reasons why you want one later on in this presentation. But it's a soilless system. And the idea here is that the feedstocks going into the system are the feed for the fish and the water. And in a perfect world, there are no waste streams. So everything would be consumed by the plants. The plants are filtering the water that goes back to the fish. That doesn't always need to be the case. But in the original models, it was a loop, a closed loop where fish produced the waste that became the hydroponic nutrients for the plants. The plants scrubbed the water of those nutrients, and then that water went back into the aquaculture facility. And we'll talk about a couple different methods of variations of that, changes that have been developed over the last few years.
Perfect. So moving on from there is this one is talking about why the greenhouse structure matters and why do you actually need a greenhouse when you're doing an aquaponics facility. So if you are doing what Paul kind of just discussed, where you are circulating the waste from the fish back into what is shown in this picture here, which is a deep water culture pond, these heads of lettuce are being grown inside of a greenhouse. And that greenhouse, what it is actually doing is providing environmental control, biosecurity, energy, resource efficiency, systems integration, everything shown on that bulleted list there. The greenhouse structure is providing all of that for the produce growing itself. So in the States and in Canada as well, pretty much all around the world, produce is grown a lot in greenhouses. And essentially what you're doing is providing that same type of structure and environment for the produce, and then adding the extra variable of using the fish waste to actually produce the nutrients. So you're able to grow top tier quality when it comes to produce because you're still in a greenhouse environment and you're not growing outdoors. You're not growing, you're just growing as a typical greenhouse grower would go in that type of position.
So in a strictly coupled design, which is a lot like the original models of the aquaponics facilities, meaning the fish directly impact the plants and the plants directly impact the fish, that's a coupled design. The reason why you need a greenhouse is you need to maintain consistent production of the vegetables year-round in order to adequately filter for the fish. Unless your fish populations are up and down, if you have a steady state situation, you can't expect that you're going to be able to grow plants year-round with the same consistency, same amount of timing, the same sizes, everything you're looking for in an outdoor environment. The very first aquaponics facilities were actually built to operate in islands, as I mentioned, and they didn't have a greenhouse. They would sometimes have some bug screening, or sometimes they were just hydroponic raceways out in open air. And of course, that had all kinds of biosecurity concerns. Now you got all kinds of pests inside your crop. Additionally, what happens if you start to take that model and you take it off of a tropical island where you can grow 12 months out of the year, and you start to bring it up into the Midwest where you're going to have snow on the ground 3 months of the year? Obviously, you can't rely on a hydroponic system outside in freezing conditions if you're going to be trying to use that hydroponic system to filter the fish effluent water from the aquaculture side of the business. And what I would say too, why the greenhouse matters so much, is in my experience, the majority of the revenues generated by aquaculture facilities is actually in the greenhouse portion of the operation. You grow plants at a much faster rate than you raise fish. So your throughput in terms of the amount of production you're doing is probably 10x higher in plant material than it is in fish in meat or whatever you're raising your fish for. So the greenhouse is really the engine of the aquaponics facility. It's what's cleaning the water. It's what's producing the most biomass. It's what has I would say arguably the most control, and the fish are kind of more or less the source of nutrients for the greenhouse, the source of fertilizer for the greenhouse.
And also with it too, Paul, having the greenhouse allows you to actually create an aquaponics type of facility anywhere in the world as well. You don't have to be in a climate where you already have the right exterior temperature and humidity to grow lettuce. You're able to make that environment inside the greenhouse essentially anywhere you want it to. So you expand the possibilities of where you're geographically able to produce these type of systems.
We have them pretty far north, places like New York, Colorado, Idaho, Montana. There's a number of places, even up in the Pacific Northwest, where you don't have an adequate growing season 12 months of the year for primarily leafy greens. That's what we see most people raising inside these aquaponics facilities. And there's a couple of reasons for that. The nutrient profile of the water or the fish effluent is heavy in nitrogen, and leafy greens prefer nitrogen. They tend to have less phosphorus and potassium. And so those are the nutrients that you would want for a vine crop, for example, or a fruiting crop like a tomato or a cucumber. You would have to supplement those nutrients a little bit more if you want to do a vine crop. And you're definitely not going to raise a vine crop in Montana in the winter months without 9 months of the year without a greenhouse.
Exactly. So moving on from that and kind of talking about the different components of what an aquaponics facility actually looks like. And this here is more focused towards the commercial side of things and not so much on the hobby or residential side. But on the commercial side, you might see different terms such as head house, fish house, processing house, or greenhouse kind of thrown around. And they all have their independent responsibilities and purposes. And the way that you can connect them all as well as utilize them is very unique and something that's very crucial when you're in the early stages of the design. So the head house is a typical head house that you would see on, maybe a nursery operation. But what you're doing out of the head house, you might have your offices, your restrooms, meeting rooms, just general admin function out of the head house. And then you might also have a water management room where you have some of your water tanks. You might have some filters or anything along those as well. That can also kind of be thrown in the fish house depending on the design, as well as just some of the electrical panels and service. So the head house is kind of just a general meeting area. It's kind of the admin space. And then the fish house, so this is kind of self-explanatory. This is going to be where the actual fish are held. And inside the fish house, you're going to have your tanks, your raceways, however you are trying to cultivate your fish and grow them. That's going to be inside the fish house. And within that as well, you're going to have your distribution piping, some pumps. You might also have some filters in there. Sometimes all of that's underground. Sometimes it's overhead. There's a lot of different ways to kind of do the fish house, but a lot of it's going to be dependent on which form or method you're actually trying to raise your fish in. And then the processing house, this is going to be, sometimes this can be combined with the head house, but what the processing house essentially is where you're going to be harvesting your produce, which is more than likely going to be your microgreens. This is where your loading docks are at. So this is where you're shipping and receiving everything at. You might be packaging some of your microgreens out of it. This might be where you might harvest the fish in the fish house, but then transport them to the processing house to do final packaging or loading into the fish truck beforehand. And then lastly, you have the greenhouse, which obviously is going to be where your actual microgreen production is based out of. So what might be in there is typically it's going to be a deep water culture pond. Sometimes you could get away with an NFT system or a grow gutter. They're not as common. Typically, it is going to be that deep water culture system. And then you're going to also have all of your cultivation equipment in there. So you're going to have the light, the fans, the distribution piping for the irrigation and everything along those. But what is shown here in the photos is up on the top. That is the greenhouse portion. And then down here at the bottom, that is the head house and the greenhouse combined together. And you can see in the middle is the fish house. It's a little tough to see in that photo, but you can see they're all gutter connected together to operate, efficiently and have things be able to go from one house / room to the other without causing more inefficiencies along those lines.
So on a large commercial project like this, typically what we see is the head house have a locker room, because if you're going to be working in an aquaculture facility all day long, chances are you're wearing rubber boots and things of that nature. Also, a lot of times in the head house, you'll see a lab, a water lab for testing. Typically, you see water tests done daily, at least nitrogen levels, dissolved oxygen, pH, those kind of key metrics are measured daily in different areas of the system, depending on whether you're a closed loop or whether you're going to be a decoupled system. I'll get into that in a second. Of course, your electric service panels, that all makes sense to keep that inside the head house building as well, away from the fish and the water. Your fish houses, these can be set up in different ways depending on how you're growing. But one of the biggest things that people don't realize they need is a pretty sizable biofilters, basically, is what they come out to. Bioreactors is what most people call them. Giant water tanks that convert the nutrients from the fish waste into liquid fertilizer for the plants. And so there's a series of tanks and filters that can be set up all different ways to make that work. And that's all usually done inside the fish house. And typically speaking, the fish house is maybe 1/4 the overall footprint, and the vast majority of it is going to be greenhouse, just because it takes a lot of plants to kind of clean that water up. And again, the plants tend to be where the biggest revenues are coming from.
And a big thing that I think a lot of people typically forget about is the packaging of the produce afterwards. And I've seen examples before where people were making significantly more money just packaging other produce cultivation facilities. They were taking in their product, packaging it, however that company may have theirs packaged, but they had the actual equipment to have the packaging automated and was able to make twice what they were making on the actual produce cultivation side just from the packaging. And the packaging can take up a lot of square footage as well, depending on how automated it really becomes.
And just for good food practices, a lot of times what we're seeing now is two separate streams for the finished product. You'll have one for the fish, oftentimes, and they'll go into a separate packaging area, and you might have a separate area for the produce, which is handled differently. It's got coolers and whatnot, where fish, sometimes you might be having people pick up live fish and put them on ice. Other times you're doing the processing itself, and then you have to deal with what they call the offal, the offal, the guts and stuff like that gets processed into typically some kind of fertilizer as well. But oftentimes you don't see the fish and the plant material being processed in the same building. Sometimes those are two separate buildings. And a lot of times you'll see the fish be basically separated from the rest of the greenhouse facility, because more often than not, the fish are not looking for the same environment as the plants. They're at a different temperature. They don't necessarily need sunlight. Our first photo showed the fish building dark. A lot of times, when you're raising fish, they're used to eating other fish, so they might eat each other, or they just like to be at a lower temperature. If you allow sunlight into the fish building, now you're allowing an opportunity for algae to grow on things. You're allowing an opportunity for the sun to hit the water and heat up the water temperature. Lower water temperatures hold a higher dissolved oxygen. So there's a lot of reasons to try to isolate the fish, separate from the greenhouse so that you can create a perfect climate for the plants. And really, you're just focusing on water temperature in most cases for the fish.
Mark, you mentioned in one of those bullets a raceway. What is a raceway in this context?
So, Paul, you might be able to give a perfect example. Yeah.
I'll go ahead and do that. So the two main types of tanks that you see in aquaculture processing are circular tanks. I'm sorry, aquaculture production are circular tanks where the water creates a circular pattern all the time, and the fish kind of stay stationary in that circular flow, or they might swim against that pattern. And the nice thing about a circular tank is, just like a whirlpool in your bathtub or anywhere else, you can kind of, once you get that circular flow, most of the solids settle to the very middle where there's typically a drain. And the other thing about circular tank is sometimes you're actually able to drain the fish right out that drain as well, pump the fish into a processing area that way. Very nice method. Circles don't tend to be the greatest for space utilization in rectangular buildings. So the other option is to do raceways, which tend to be more like a straight track. And so they tend to be like a large fish tank, a rectangular shaped fish tank, where water pours into one side of the raceway and empties out the other. And what happens is the fish are flowing. The fish have to constantly swim all day long. It's like being in a river because you have a current and the water's coming from the top of the raceway to the bottom. It's being dumped in the very top and being overflowed out the bottom. So they have to swim all the time like they're going upstream. And this allows you to raise healthier fish, and they raise them faster. However, it's not the best for capturing solids. A lot of solids fall. You have much more surface area at the bottom, and for the same amount of flow. So a lot of solids settle to the bottom. So when building a raceway type of tank, you have to appropriately stock the tank. The fish are the cleaners. The more fish you have in that raceway, the cleaner it's going to be. If you have a big raceway with hardly any fish, almost all the solids are going to settle to the bottom, and you're going to create a giant biofilm down there, and you're going to get a bunch of chemistry that you don't want in the aquaculture building. Where if you do a circular tank, it really doesn't matter how many fish you got in there. It's all those solids are getting spiraled down to the very center drain. Two different ways of doing the same thing. It's just how do you want to exercise your fish and keep those tanks clean, and how much water do you want to push through those tanks? What's the retention time of each tank need to be? And that all comes into the sizing of your equipment. So the sizing of your pumps, how you're delivering oxygen to the tanks, how many fish you want per tank, what your housing capacity is, your holding capacity is. So those all come into play when sizing the stuff that goes inside of the aquaculture building, or what we call the fish house oftentimes.
Mm-hmm.
And then moving on from there, so when you are first starting to look at doing an aquaponics facility, the design portion before you cut any checks or before you put any stakes in the ground is just as important as the actual construction portion as well. So when you are in these early stages of design, there's some really important things to look for, and a lot of them are shown here on this bulleted list, but just to read off a couple of them is structure, airflow, and the fish house versus the greenhouse. There's two different styles of airflow you want. Again, with temperature control, you're going to want to have a different temperature in your fish house than you do the greenhouse. The greenhouse is going to be a little bit more difficult to control due to the solar heat gain, so you might have to have bigger fans in there. Automation capabilities is going to be a really big thing. How are you going to run this facility once it's up and built? Are you going to have 20 employees, or are you able to put in enough automation where that 20 employees goes down to 4 employees and saves you on the operational expense side? Light transmission is going to be a big thing. As Paul kind of said earlier, obviously you want high light transmission in the greenhouse to help grow the microgreens, but in the fish house, you don't necessarily want that high light transmission due to the potential of algae growth and everything else that Paul kind of talked about down there. The flexibility and expansion capabilities of the actual facility is a big one. So if you don't have the capital up front to do an acre of aquaponics, you can only do, say, 5,000 square foot to start. Do you have that master plan designed? is the structure that you're looking to put up, is it easily expandable? Can you kind of change the layout of that greenhouse structure? A lot of that's going to be a key play in what the future of the business operation looks like. And then your maintenance requirements, you're going to have maintenance on any structure, any system, anything that you put into there. But are you choosing a system and a structure that has lower maintenance, say over a 10-year period, or are you picking one where you're going to have to, say, fix a roof vent every 2 months because it's an unreliable roof vent? And then lastly is just the compatibility of the head house and the greenhouse space together. Is it possible to gutter connect them? Do you need transfer corridors? Have you planned out how wide of a transfer corridor you need and at which locations? And by gutter connecting them, you're able to house everything under one roof, even though they are separate buildings. You could walk from the greenhouse to the processing building to the head house without ever actually having to go outside. And if you're in a geographical location where, say, it rains or snows a lot, that's going to help save just efficiency on moving from one end to the other. And using transfer corridors will help a lot with the gutter connected houses as well.
So we'll talk a little bit about what to look for in a greenhouse in the next slide, but some things that we might touch on here about the other ancillary buildings for the operation, the commercial operation. We talked about the fish house, we talked about the head house, and we talked about the processing area. A lot of times we build these out of the same substructure, same framework as the greenhouse. We build just like a greenhouse, but we cover it in a non-transparent or insulated metal covering, so you can have a different function inside that space and meet all the code requirements for that separate function. Let's say offices and restrooms and things of that nature, meeting spaces, even places where you might give tours or sell produce out of the front. So we used to build a lot of our fish buildings out of metal. So we still had the metal framework, but we used to cover them in insulated metal roofs and walls, and they've held up very well. But more recently, we've been finding that they make non-transparent polycarbonate materials that you could put on a roof, and you still get a reasonable R value. Remember, in the fish house, you're really more focused on the water temperatures, not as much on the air temperatures inside there. You still get a reasonable amount of insulation, but you lower the cost to construct the fish house. Plus, plastics don't rust. So, these fish houses tend to have a lot of water all over the place. They have pumps throwing water up in the air, aerators throwing mist up in the air sometimes, and water in the ground. It's just the nature of an aquaculture operation. And yes, you can do that with a metal-sided building, but we're finding out that polycarbonates actually might be a better option for those guys, and it's a lower cost approach to getting built. Plus, these are considered low-energy buildings by the building code because they're aquaculture buildings, so they don't necessarily need the high input cost of insulated metal. We tend to cool those spaces, heat and cool those spaces the same way we heat and cool the greenhouses. So the same heating systems, unit heaters more often than not, so they dry up the air, or evaporative cooling processes for cooling that space and the proper climates. So we're finding that greenhouse substructures with a slight change in the materials that we put on top of them tend to be almost the ideal structure for an aquaculture housing, whether it be gutter connected or its own standalone building with the water being piped over from one building to another. The other nice thing about this is they're easily expandable. Greenhouses are designed to be gutter connected and expandable over time. And if you have intentions to grow your business and double it or triple it, you don't want to probably buy all that aquaculture space up front. It's pretty expensive, all that equipment. So maybe you want to just put those on one house at a time, or so many houses at a time. And that's the nice thing about using a greenhouse structure for that. You have one foundation design that's the same as for the greenhouse as it would be for the head house, as it would be for the processing building or the aquaculture building. It's all the same foundation, same build crews, same manufacturer supplying all the equipment and materials, same trucks are coming on. So there's savings and utilizing the same structure and just changing the way that you outfit it for a head house or a fish building or a processing building.
And something down here too to note here is this photo down at the bottom is of a fish house that is currently being installed, but it's just a foundation. But when you look at aquaponics, there's so much water involved, whether it's the water that the fish are growing in, whether it's the nutrient-rich water that you're sending to the crops, the microgreens at the end. And due to all of that water being available, you really need to think about how am I going to drain these tanks? How do I have an efficient way to move water from one tank to another? Am I using grates in the ground such as this, or am I doing all above ground piping? So there's a lot of water to be handled, and the design on how water is going to be moved is crucial. And you can just see in this photo below just how many grates are being installed. That is going to make it a little bit, the design just more complicated and more complex than a traditional, just regular greenhouse irrigation system.
Yeah. Anytime you put something in the ground, I love that you use this photo. Anytime you put something in the ground, it takes a lot of forethought because you don't want to be digging it up in the future. And in a greenhouse environment, it's oftentimes pretty nice to have all your plumbing in the ground, so they're not getting, so that water that's sitting in those pipes aren't heating up in the sun. If you were to just pipe it all above ground, it's nicest if it could be in the ground. However, it's almost impossible to change once you've got it in concrete. So it takes some forethought.
Alrighty, and then moving on, we have the best types of greenhouse structures for aquaponics. So basically a real quick overview of this one is a lot of this is going to be dependent on, are you doing a commercial type of build? Are you doing a residential hobby house type of build, or are you doing more of an educational where you just want people to be able to see how aquaponic works? And depending on what the selection is for that, a lot of these options are going to be different and variable depending on what you're actual trying to achieve at the end of it. So at first, we're going to look at gutter connected houses versus Quonset style houses. So on a commercial scale, we highly recommend doing gutter connect houses, just so you can see in this photo down here, you can see there's a greenhouse to the left and to the right of it, and you're able to go much further distances on those, whereas a Quonset is going to be much more of like what I would call a ground to ground, where it's going to be really good for residential and hobby houses, and it's going to be a pretty low capital expenditure up front, so you're able to kind of get your feet wet with doing the whole aquaponic side of things, whereas a gutter connect is going to be much more for a business operation where you're trying to actually run a business out of it and have that larger scale. And then when it comes to the actual type of structures, there are a lot of different greenhouse structures you can do aquaponics in. Some are better than others, and what we would typically see is an A-frame or a multi-peak. And for Prospient, that's our Vale greenhouse or our Venlo greenhouse. Being able to do those and have those gutter connected. This photo above is showing an A-frame, which is a Prospient Vale in this photo. And then you can also look on that cheaper end. It's going to be less efficient and it's not going to be as good operationally, but looking at like an arched, or what Prospient would call our Grand Teton style. So this could be Gothic, or it could just be your traditional Quonset style roof. And the reason why we're looking at these ones is a lot of them is going to have to do with the roof covering. So what Paul mentioned above or before, when he was saying you can do the non-translucent polycarbonate, you could basically do that on the Vale or the multi-peak house. But when you're doing more of a Quonset style house, it's going to be harder to have that rigid roof. So it allows more flexibility when you're doing either a Vale or a Venlo style house, because you're able to do double wall polycarbonate. You can do single wall polycarbonate glass or polyfilm on most of those. Whereas when you're doing the Quonset style house, you can sometimes do the double wall polycarbonate, but it's almost always going to be polyfilm. So you don't have that rigid roof. You just have a thin 6 millimeter plastic up there, sometimes 2 layers of it. It's just going to be much more efficient in the long run from a commercial scale to do a rigid roof. But for a residential scale, if you're not looking to have that high capital expense up front, might be more efficient to do what I would call a polyfilm type of greenhouse.
And A lot of this is going to be dictated by your building department too. But if you're building in a rural environment, you might be able to get away with doing a non-permitted ground-to-ground Quonset style house. But if you're starting to build this in a more residential area or more urban environment, then you're going to probably need to go look at the engineered structures that would have a rigid covering, and they would allow you to meet the energy requirements by the building code, the energy savings requirements by the building code, using a rigid cover. So one thing I want to mention here, you have different levels of cost associated with different greenhouses, and your ground to grounds being kind of your lowest cost, your easiest entry point, and your gutter connecteds being your higher costs, but in terms of longevity and maintenance and flexibility, they've probably got more options available to you. Now the gutter connects, if you're talking about a large scale operation, are always going to be more energy efficient than Quonsets. And that's because they have less surface area for heat loss than a ground to ground would have for the same amount of square footage footprint. The other thing that's nice about the gutter connected house is you can add more systems to them. So in this picture here, you'll see, it's hard to see, but up in the truss, there's actually a curtain system that's fully retracted, meaning that it's letting sunlight come in. But that shade curtain system, or also sometimes called an energy screen, it allows you to almost double the R value of the roof covering. And heating is typically the second largest cost of a greenhouse operation, depending on where you're at, obviously, in the country. But usually it's the second largest cost of a greenhouse operation. And so reducing that cost by half by adding in an energy screen is a significant first step and to getting better ROIs out of your structure. So more often than not, we see large commercial operations go to the gutter connected design for ergonomics, for ease of the foundation, for ease of expansion, for energy savings. And then on occasions, we'll see people do the soft film, the polyfilm covering on either a ground to ground, an individual house that is, or gutter connected structure. The polyfilm, whenever you're raising a produce crop, is usually a little less desirable because it's more likely to have condensation form on it in the cold winter months, and then that condensation is more likely to drip on your crop if it's not properly captured and taken out of the building, taken away from the crop. So you could get some drips, which would result in other issues with your crop if you're doing it in a polyfilm house. So 90% of the time when we see produce being raised in a greenhouse, it's a rigid cover, whether it be polycarbonate or glass.
And another thing too is the polyfilm you're going to have to replace every 3 to 4 years versus every 15 to 20 for a rigid covering. So when you go and replace your polyfilm, either you're going to introduce all of your produce inside that greenhouse to exterior conditions, or you're basically going to have to clear out the entire greenhouse every 3 to 4 years just to replace the roof. So there's business ROI associated with that as well.
Yes, certainly there is, and crop security too. Yep.
Mm-hmm. So moving on from that, we kind of are getting into more of the actual crop health side and best practices on managing the actual crop health. So when looking at aquaponics, a big thing that you're going to want to take into control is the water chemistry and how are you balancing that and how are you monitoring that. That could be from a nutrient level, it could be pH, it could be EC, DO. There's a lot of different metrics that you can measure when it comes to the water chemistry. But the way I kind of look at it, and sometimes what I say is you can't improve or do anything with any metric if you're not measuring it. So you can't log it, you can't improve it if you're not measuring it to begin with. So measuring the water chemistry in all of those different metrics is extremely important on an aquaponics facility, just because you aren't necessarily making the recipe for the plants. It's coming from the fish waste. And sometimes, as Paul discussed a little earlier, depending on what crop you're growing, you might need to add extra you might need to change the composition of that water. You might need to add more phosphorus, or you might actually need to take out some of the nitrogen that the fish are adding to the water. So you might need to dilute it with regular, say, RO or diluted water just to help with the nitrogen levels. And again, monitoring all of that's really going to help. And every single crop is going to ask for a different water chemistry level and everything along those lines. So really making sure that you're monitoring all of that is super, super important. And kind of getting into, again, how all crops are different, as we've discussed. Most of the times it's going to be microgreens, but if you are looking to do a different crop, your light levels, your temperatures, and your airflows are all going to be crop dependent. So lettuce per se is going to have lower light levels and lower temperature levels than, say, if you were trying to do basil or tomatoes in this facility. So understanding what crop you're growing and the environmental parameters that that crop really calls for will be huge. And then lastly, just keeping the produce area in the greenhouse clean, doing daily inspections, logs, trying to get rid of algae as much as possible, just making sure that you are giving the plant everything you possibly can to help it survive and thrive is going to be very important in this.
So we'll touch on this in a few more slides, but it is worth mentioning right now that the plants typically want completely different chemistry from what the fish are doing. And so in a strictly coupled system, you have to figure out how to draw out all the nutrients the plants with the plants that the fish don't want, and how to add all that nutrients back in with the fish food that the fish and the plants both want. And that's a strictly coupled system, a loop, where water goes from the fish to the plants, plants back to the fish. But what we're seeing these days, and this is much more, I think, practical and a safer way to run your operations, we're seeing decoupled systems where water goes from the fish, water and nutrients, feed, goes from the fish to a biodigester. And that's a separate component inside the fish house, typically speaking. And that component separates solids from liquids in the waste stream, and also mineralizes most of the fine solids into basically molecules of fertilizer. It's a fertilizer factory. And what it's doing is converting one type of nitrogen, ammonia, into nitrite, and then from there into nitrate, which is the preferred form of nitrogen for plants. And it'll do the same thing with different types of phosphorus and all kinds of other micronutrients that the plants need, micro and macronutrients. So that water in a decoupled system tends to go from the fish to the biodigester to the greenhouse, to the plants, but never really goes from the greenhouse back to the fish. In fact, we've got some customers that have never emptied the water in their greenhouse tanks, in their greenhouse ponds. They're growing plants where the salt levels are not building up too high. Measuring EC on a regular basis is pretty important to make sure that you don't have one nutrient that's like a micronutrient that's becoming toxic because you have a higher concentration than your plants desire. But we're seeing more and more these days the decoupled systems, which I'll talk about in a further slide, where you're able to add in supplements to the hydroponic system to raise other plants besides just leafy greens. So you're able to add more chelated iron. You're able to add more phosphorus and more potassium. So now you can start growing besides just leafy greens, you can grow vine crops or spinach, for example, things of that nature. So by decoupling the systems, you're able to almost run your greenhouse as its independent hydroponic system with the fertilizers coming from the fish building, and then you could supplement those fertilizers as needed. And then the other thing is the fish, they don't want to be at a high pH, they don't want to be at a low pH like the hydroponic greenhouse does want to be. Hydroponic greenhouse might want to be at a pH of 6, and the fish might want to be at a pH of 8. And so if you're doing a strictly coupled system, you're really not optimized around either one of your two crops, your fish or your plants. Where if you do a decoupled system, you can dial in the exact water needs for the fish, the right temperature, the right pH, the right amount of dissolved oxygen, and you can do it in the right amount of nutrients, nitrogen and water, usually at a very low level. And then you could do the same thing for your greenhouse and still not have any real waste streams.
That's perfect. Yeah, I think that's a really good way of looking at things as well, Paul. It's just those two different systems, and kind of going back to what we were talking about earlier, is making that decision in the early stages of design before you really start looking at building one of these. Really making sure you understand what systems you want to put in and how the operation works with inside of that own system. But moving on from there, we have ways to kind of help your operation become more efficient. You know, how can you cut costs? How can you save energy in this type of a system? And there's plenty of different ways. A lot of these ones included in this list here are going to be mostly greenhouse specific. But the first one is, are you going to do supplemental lighting? In most cases they are, especially on a commercial scale. And when you do that, are you going to do LED versus HPS? The story is, you know, everybody knows the story of LED versus HPS. You can get the same amount of light output from an LED with the lower electrical input cost. So LEDs is going to help with your electrical bills at the end of the day. And then a big one, and I would say this is probably one of the most important ones, and Paul touched on it briefly earlier, is an energy or a shade system. And are you going to do a single or a double curtain system inside of this house? And the example that I like to use is, if you're looking to grow lettuce, say at 14 DLI on any given day, but you're in Colorado where me and Paul reside, during the summertime, you might get a DLI of 30 out here. So you are actually, the sun is actually giving more sunlight to that crop than you want it to get in a given day. And without a shade system or whatever you're using to block out the sunlight, that plant's going to get cooked. You're not going to be able to maintain optimal levels. So by having that shade system, you're able to block part of that sunlight back out of the greenhouse, as well as the solar heat gain that comes with it. And then you are also essentially creating a barrier where you have two different levels in your greenhouse. You have above and below your shade curtain. So now you have two different environments that you can control. You don't really care too much about the environment above the shade curtain because nothing's growing in there. But everything below the shade curtain, that's where you're actually trying to control the environment. So from just a volumetric perspective, you're cooling less volume, a smaller volume of air below the shade curtain when it's cooled versus when it's not cooled. So that's the energy in the shade system. Variable speed pumps and aerators. That's just going to help with energy control depending on the season and how much water or air is required in your pond. Insulation material is going to be a real big one for your head house, your processing house, and your fish house. Insulation is also going to be a big thing in greenhouse as well. And again, as Paul discussed earlier, that shade system / energy curtain can actually double the R value of your roof. So you're actually going to be losing less heat in the wintertime if you have that shade system pooled. And then a big one when it comes to cost savings is automation. And again, this is probably more tailored towards the commercial growing side of things. But on a huge scale, say if you're doing an acre of aquaponics, it's your biggest cost is going to be labor at the end of the day. So what can you implement before you build this facility to automate it the best that you can to, from the example earlier, take your total amount of employees picking heads of lettuce from 20 down to 5? What are you able to do to cut that labor cost? That might be automated cultivation systems. It could be automated environmental control systems. Quite honestly, we could probably do an entire webinar series on automation alone. So there's probably not too much we want to get into there, but automation is going to be a really big key in just helping your business thrive and save as much money as possible. And then moving on from this one, we have lessons learned. So as Paul said before, together we've worked on a fair amount of different aquaponic facilities, whether they have been commercial, residential, or educational. We've done pretty much all of them, and we've seen what works, we've seen what doesn't work. And personally, my biggest thing that I always see is when people try and cut corners in the beginning, save 1 or 2% of the capital cost up front, ends up bringing way just horrible headache at the end of the day. Actually end up losing money on that front. So that would be kind of my biggest thing. And doing, for commercial, obviously doing gutter connects and a lot of the stuff that we've been talking about. Paul, do you have any specific real world scenarios you would like to discuss?
Well, what I always tell people is what we've found works and doesn't work. People always tend to undersize their head house, and they don't take into consideration that you want separate streams, separate processes for fish processing and for leafy green processing. A lot of times with the leafy greens, you have the whole head going into a processing house and just one cut being done at the base of the head to cut the roots off. And then either the leaves all go into a hopper for a mixed bag, or the head goes into a clamshell. And that's nice and clean. That's pretty easy to visualize. But for the fish processing side, it's a little bit messier, right? You're going to have a fish pump, which takes all the fish from one tank to another in most cases. Sometimes this is done by net and putting them into a temporary container and moving them over to the processing area. But more often than not, it's a fish pump, and then you have a whole fish processing line that guts the fish and deals with all the elements that are not marketable, not sellable. And then you just have a nice fillet at the end of the day that goes into, usually it's a fast freezing process, and then into a freezer. So you have to keep in mind, these are probably two separate areas, work areas with two different functions altogether. They may all go in the same, ultimately go in the same head house for storage, but you're going to have a different cooler for fish than you will for produce, right? Because you typically, bring the fish down to a lower temperature than you are bringing the leafy greens down to. So a lot of thought needs to go into the process flow of both the water for the systems, and then secondly, I'd say the actual end products that you're trying to sell. You're going to need a nursery for the fish, so a smaller area besides your production tanks. You're going to need a nursery for the greenhouse, where you start your seedlings out before they go into the final spacing for the grow out tanks. Deep water culture has really been popular. We've seen that as a great lesson. You see people do it both as NFT, nutrient film technique, and deep water culture. Nutrient film technique, you've got to really dial it in because you don't have as much of a reservoir of water to draw from. So the plants draw nutrients out of it quicker. It changes temperature quicker. It takes more adjustments, more monitoring, versus a massive tank of water that's used in deep water culture. It doesn't swing as quickly. It also tends to stay cooler. You got to think about growing in a greenhouse. If you're trying to do a passive greenhouse in some environments, let's just say down south, your root zone is going to be too hot for an NFT in most cases. It's going to be the same temperature as the outdoor air temperature, and that plants don't like to have their roots that warm. So you see deep water culture being more popular in hotter climates, especially if you're doing a passively ventilated greenhouse. More often than not, though, because people want full control of the production, they want to do a mechanically ventilated greenhouse and have that under complete automated controls. And that allows you to insect screen a little tighter. That allows you to dial in your temperature to a degree or two of your target temperature. It seems to be a more practical way for year-round production for consistency. Lastly, the other thing I see a lot is the use of chillers. We'll see chillers utilized for maintaining cooler water temperatures. Let's say you're trying to raise spinach or something that might potentially bolt in a hot greenhouse during a summer month. Just cooling that water temperature and using a deep water culture methodology versus NFT, you'd have to almost chill the water. It'd have no oxygen left in it if it was 90 degrees and running through a long NFT run. So just careful monitoring of your temperatures, your EC, your pH, your dissolved oxygen is a big player in this thing. You have to think about how you're going to supply oxygen to both the plants and the fish. Those are the important lessons I've found in building these facilities, and also just being able to decouple them. I see one of the questions in our chat is about how do you scale an aquaponics system? I oftentimes, that's a very important question, but I oftentimes think about how do you even get an aquaponics system started before you start even scaling it. You have to put fish in it initially, and you're usually don't have access to full-grown fish. So you have to bring it in you have to kind of bring fish in stages and start growing them out. Well, when the fish are very little, they're not producing a whole lot of fertilizer, a whole lot of waste. So how are you going to manage that? Decoupling the greenhouses from the aquaculture facility, being able to have the fish building have its own standalone filtration system, essentially, that'll run it just as a regular aquaculture facility until you get the fish count up to the point where you have nutrient levels high enough that you can actually start growing plants, is important. And the same thing's true about your plants. You can't start, let's just say you have a fully stocked greenhouse. Aquaculture building. You can't just load the entire greenhouse full of the same stage plants, right? What are you going to do when they all have to be harvested? So you'd have too many swings in your system. So you're trying to get to a nice steady state where we're harvesting so many fish a month and so many plants a week, so that the profile, the nutrients don't change much inside the system. Well, if you decouple those two systems and you make it so that the fish side works on its own, it's standalone, even though it is symbiotic with the plant side. If you're using the fish water, you can raise plants off that, but it doesn't have to be the case, because you might have a greenhouse down for maintenance, or you might have a change in the crop that you're trying to do, market shift, things of that nature. So you're getting rid of all your lettuce and you're switching to just spinach, or vice versa. Being able to decouple those two systems allows you to start them up easier, because like I said, if you only have 1/10 the fish mass that your ultimate size is going to be, you're not going to be able to grow any marketable plants off of that. They're all going to be nutrient deficient, in my experience. But what you could do is you could have the water going one way from fish to plants, and in that pathway from fish to plants, you could supplement that, so you get your hydroponic operation up and going. It's completely stocked. You have every greenhouse completely full of plants, all different stages of growth, so that you don't have a whole lot of swings when you harvest. And then you could bring the fish side online, slowly but surely. The fish some fish take 6 months to grow, some take a year to grow to marketable size. So where a plant only takes 60 days, and all of a sudden you got a marketable size head from the time you seeded it. So that's what I would say is the most important thing, is planning the way that you're going to bring online the systems, and then expansion actually becomes much easier if you make it modular. Adding one greenhouse, gutter connecting one greenhouse to an existing greenhouse superstructure is no big deal. And if you've already have the fish building set up for expansion, remember I said almost everyone builds their head houses, fish buildings, and processing area too small. Then they have to figure out how to do an addition onto the thing. If you have your fish house set up so that all you have to do is go off your trunk lines, your water lines, and add another tank to it, add another biofilter to it, a biodigester to it, and then send another run out to the greenhouse, that's not that hard to do.
Yeah, I think just building in the adaptability of your structures and your systems is so crucial. Well, because there's always going to be unexpected challenges, even if you build it and you don't have any plans on expansion. Once it's up and running, it's not going to operate 1000% like you expected it to on paper. There's always going to be small little challenges here and there. So building in, say if it's for the transfer of the water, adding in an extra loop to it that you can stub off of eventually and do new type of experiments or new types of runs or anything like that. Just having the adaptability of your systems is going to be huge. And that the other question in our chat, that's kind of the answer. That is being able to separate such things by just having the extra loops and having the adaptability of it all.
Okay.
Putting in bypasses, and I truly believe that building the head houses and the fish buildings and the processing buildings I'm getting at, out of, let's just say, our veil structure, our A-frame style greenhouse, and just cladding it differently and maybe putting some different systems inside of it. I feel like that's a great way to be able to expand. It's much easier to build both in length or off to the side, gutter connecting, expand a head house building out of a greenhouse than it would be a standard brick and mortar.
All right. Well, we are up at the hour. So that was fantastic information. I had a whole lot of questions on myself, but I'll ask you privately. So thank you very much. I appreciate it. If anyone on the line has any other questions, please feel free to email Mark or Paul directly. Their emails are on the screen. Or else, if you forget those, just go with info@prospiant.com. That comes to me, and I'll find out who needs to answer. Thanks again, and enjoy the rest of your afternoon.
Thank you.
Thank you, everyone.
Thank you.
Bye-bye.